Again, my phone is glitching on me, but I think it ended on a good spot. We'll pick up again here starting on property 9. It's an extension of property number 7. And so what I'm going to do is actually write this out. I'll use a different color and kind of write this out over to the side here. What happens is if I take property 7 and expand it, but using the same thing in the parentheses. So let's say I had log base A of, and I'm just going to use, what am I going to use here? Let's use M. Let's do M and M. Sounds like a candy. Log base A of M and M. Well, we know that by property number 7 is log base A of M plus log base A of M, right? I split it up. But now if you think about this, the first side is actually log base A of 2M. Oh, no, I'm sorry, not 2M. It's M squared. I should write that differently. Let's do this. Let's just ignore that and go above. Log base A of M squared. There it is. And on this other side, you have two of the same terms, so it must be 2 times log base A of M. All right, these two things on the left are equal, these two things on the right are equal. They're equal to each other down here, so they must be equal to each other up here. All 4 of these expressions are equal to each other. And now if we generalize this, what we're going to be doing is we're going to, instead of doing a 2 here, I could use any number of multiples and get any number of terms here. So if I wanted if I wanted 5 m's, I could have 5 terms here and a 5 and a 5. But everything is related. And so in a general sense, if I wanted to take log base A of m to the r, then that is equal to r times log base A of m. Alright, so again, it's an extension of property 7 where you have the same factor repeated multiple times. Okay? And so in practice what it does is if you have an exponent on the inside of a logarithm, the power actually comes out as a coefficient to the logarithm, which is very useful, especially later on when we solve some equations in a couple sections. Alright, the final and 10th property is one that's going to be handy for calculating logarithms on your calculator. It's what we call the change of base formula. Again, I'm not going to go through the argument for this, but the proof of this formula is definitely in your book. I just read it a little bit ago to make sure it was in there. But basically the idea is this. If you have a logarithm, we call it log base A of m, you can actually turn it into any other base that you want. It's kind of weird, but it works. But to do that, you need to turn it into that base. I'll call the base b. We'll change it from a to b for base. And you take log base b of m, which is the same argument, and divide it by log base b of the original base, which is a. Okay? It's a little bit strange, but it will work. And this is going to help us when we start calculating things on our calculators, because our calculators only have 2 logarithms on them. They have this log and this ln. And I should talk to you about what those are. So the log is what we call the common logarithm. Let me write this out. There's two particular logarithms that are very often used and useful. It is the log base 10. That's one of them. That one's called the common log, and we write it generally as just log of x. We just don't write the base for that one. This is called the common log. Okay. The common log has a base of 10, and we just don't write the base. So if you ever see a log with no base, it is actually a base of 10. Okay, we just assume that. The other one is the log base e. If you remember, base of e, the number e we talked about back on Monday, is that nice exponential number that we talked about. Leonard Euler was the guy who found it, and anyway, it's a very nice function when you talk about exponentials. It's also very handy when we talk about logarithms, and we're going to give this its own name. It's called ln of x. The ln is just a shortened abbreviation for log base e, and it's actually given the name the natural log. So we have the common log and the natural log. These are the only two logarithms that occur on your calculators, at least most of your calculators. And so we need to be able to, if we're going to calculate logarithms with other bases, we have to turn them into one of these two. And to do that, we're going to use this change of base formula. Okay, so just a real quick example. If I wanted to calculate, something that we've seen already, let's say log base 3 of 81. We saw that in a previous video, and we said that that should equal 4, okay? Because the power on 3 that gives you 81 is 4. 3 to the 4th is 81. But let's check it on the calculator. To do that, you rewrite this using the change of base formula. Now I'm going to change it to the common log, just because I want to. It doesn't matter, I could change it to natural log if I wanted. I'll get the same answer either way. So let's do the common log, log base 3 of 81. Let's do the common log. I don't need to write the base in there because I know the base is 10. Now the original argument goes on top, that's 81. And then I divide by the common log again, same base of 10, with the argument changing to 3, the original base. Now if you go to your calculator, give myself a little space here, if I go to my calculator and type that in, oh, you can almost not see that for the glare. I don't know, maybe that's better. If I were to type in common log of 81, close the parenthesis, or you're going to get this wrong, then divide by the common log of 3, the answer will be 4, as it should be, because we know 4 is the power on 3 that gives you 81. Okay. Now some of you actually have a newer calculator. Some of these newer calculators have the ability to put other bases in them. I'll show you quickly how to do that. If you go to your math button, okay, this math button here under the alpha, I believe, oh, where is it? Okay, yeah. So if you scroll down, you'll find it right here. It's really the 11th option down, called log base. Not every calculator will have this, okay? So if you don't have it, you just have to use the change of base formula like I just did. If you have it, click that, and you can actually fill in the base of 3, the argument of 81, and it will compute the 4 for you, okay? So that's just a little shortcut if you have a newer calculator. But like I said, not all of them have that feature, so those of you who don't will have to rely on the change of base formula.